right, ladies and gentlemen, boys and girls, Gungans and droids. It's about time that we start. Which means I need to put down this video game that I'm playing. And I need to get this dog off my lap. We don't have any viewers yet, so we can stand by just for a little bit. All right. I think we're about ready. About 5.5 minutes of listening to chill hop music is enough to to incite someone to action. Oh my. I got a little excited and just spilled my hot tea. So thanks for your patience. We're about to kick this thing off. Do we have any viewers yet? No. Okay, that's fine. I typically don't get a whole lot anyway. I'm not expecting PewDiePie numbers by any stretch of the imagination. This is quite a niche market we've got here. So welcome. Hello. Oh, bright lights. Cancel that. Hi, welcome. Welcome to our Thursday night stream. In this stream, we're going to be doing some big things. We're going to be doing an installation of a full ELK stack, which sounds really cool, right? ELK. I love that name. And we're also going to be installing Kafka. Really cool name, too. And I'm going to stop multitasking here. I promise you. And the reason for this installation is that we want to be able to do a network-based, event-driven infrastructure. Essentially, the idea is that we have a syslog message or an SNMP trap received by a collector. In this case, it'll be ELK. And that will kick off an automation job. So there's kind of a lot that has to go into it. I'm a little apprehensive now that we, me and myself, committed to doing this. we're going to see how much I can do before dinner is ready. Because all things should stop after your wife or husband or waifu or significant other, whoever it is, whenever they make food for you, you should stop whatever you're doing and be appreciative of that. So while my wife is away on an errand, and I think we'll go ahead and get started here. The hot tea is still hot, which is great. Oh, I didn't mean to be exposing this to you guys. Whoops. This is a Ansible playbook that builds out a full SD-WAN site. And it, as you can probably tell if you're looking at these lines right here, it uses a third-party network source of truth, in this case Netbox, to get all of its information on the site. Prefixes, VLANs, VRFs, default gateways, addresses, GPS coordinates, site contacts, etc., etc., etc. And we're able to actually execute this from ServiceNow, right? So it's even more ridiculous. And not only does it do the full SD-WAN site, but as you can probably see, it also sends a Slack notification whenever it's completed, and it also does the wireless stuff as well. So really interesting proof of concept. We're not here to talk about that. We're here to talk about Kafka and ELK and all the good things associated with event-driven automation. So let's take a second and kind of talk about what is ELK first, and then we'll talk a little bit about Kafka and why you would ever want to do this and why you might not ever want to do this. So ELK is a combination of 3 separate projects. They're all developed and maintained by the same company. I forgot the name of that company. I guess we can open up Google and figure that out. We're going to have to enable dark mode because this is not going to be good for my eyes. ELK stack. First thing I get is an ad saying ELK stack alternative. Thanks, Datadog. God bless you. We are live. Okay. Sorry, Byron. I know you asked me to send you a notification ahead of time. I didn't. Looks like the name of the company is Elastic. Okay. We'll skip the ads. This ELK stack is, like I said, it's a combination of 3 separate projects. Each of them have a unique purpose in life. Logstash is a collector of logs, and you can think of it as a syslog collector, but it also takes in a whole lot more than that. It's not just limited to syslog. It can take in SNMP traps, it can take in NetFlow, it can take in all sorts of things. The idea is you just send it stuff, and what's really great about it, you could send stuff to anything, really. Anything that'll listen to you. But what makes Logstash really great is it's pretty fast. I was going to say it's written in Java, but I forgot we're talking about good things. Excuse me. It has this mechanism that enables you to parse messages that you receive. And we're going to be doing a little bit of that later. Again, if we speed up the cadence of my talking here. Why that may be beneficial? Well, if you've ever taken a look at a syslog message or an SNMP trap, you know that there's a lot of garbage in there. But in reality, just look at the string itself. Like it's one message. Take a look at the message. It's one long string. It's huge. Or sometimes it's not so huge. But the string itself isn't enough to really make an intelligent decision from a machine's perspective. Like a human reads a syslog message and they say, hey, That is the fan went down on my switch. Okay, my brain tells me I know what to do when a fan goes bad. I probably need to RMA the box and get a new one. But a machine gets that message and it has no idea what to do with it. There's no kind of intelligence. It just sees that it's this long string of characters and it can't make any kind of intelligent decision based off of it. Well, that's all fine and dandy again for humans, but if you're trying to do network automation, you kind of need the machine to understand what the heck it's looking at. So with this parsing mechanism inside of Logstash, you can write a parser in this language we call Grok. Grok. I love that word. It sounds so caveman, doesn't it? Grok. I wonder if there was I wonder if Grok was a name of cavemen, right? Anyway, so Grok is this parsing language. It kind of looks like regular expressions. I'll be honest with you, I'm not a fan of either. I hate parsing messages. I hate it. I absolutely hate it. I hate regular expressions, and I hate Grok. Not that they're bad technologies. In fact, what they do is quite remarkable, but how annoying. How annoying are they? They're pretty bad. Anyhow, so that's the purpose of Logstash. It can receive messages of many, many, many different types. And then you can tell it what to do with that message after it has received it. Either you parse it and then you pass it on to another service, or you don't. You just drop it. So the second part of the Elastic Stack, yeah, it is the ELK stack. The second part of that is we'll talk about Elasticsearch. And effectively what that is a indexer, right? It allows you to take those messages that we received from Logstash and store them in a persistent database that allows us to index the messages, allows us to search, allows us to do all kinds of really great things with it. Logstash, again, is just to collect the messages and make some, you can do some parsing for it, but that by itself is not enough, right? You have to pass it to something that's going to store the messages for a long-term basis. In the ELK stack world, we can pass it to a Elasticsearch instance, and then those messages will get indexed and blah, blah, blah. Really cool stuff. The last part of the ELK stack, the K in the stack, is Kibana. Kibana is just a GUI. It's just a graphical user interface that front ends the database. So basically you would spin up a Logstash to receive the messages, and then Logstash can, parse the messages, make intelligent decisions. Hey, if it's this type of message, do this. If it's this type of message, do that. But you would want those messages stored in a persistent database. And that's where Elasticsearch comes in. So you would tell Logstash, hey, pass the message on to Elasticsearch. And then you take the Kibana, which is the GUI, and you point it at the Elasticsearch instance. And you say, I want you to render these logs in I want you to look inside of this database, and we'll render the logs, or we'll build some graphs. Everything that you'd expect from a GUI perspective, you can handle in Kibana. So all these three things combined, that makes the ELK stack. Looks like they're calling it Elastic Stack now. Maybe they always called it. I don't know. Yeah, so the idea is we're going to point our network devices to start feeding Logstash some syslog, and maybe even SNMP traps. Who knows? We'll see how dangerous we get here. And then we will write a parser on those log messages. We'll find maybe one or two types of messages that we want to take action on. One or two things that we think is interesting. So we'll write a parser for those types of messages, and we will effectively convert the string, the clear text string, into a Python dictionary. Actually, that's not true. Into a JSON dictionary that we will pass over to Kafka. Now, we haven't talked about Kafka yet, but that's effectively the function of what we want to show today. We don't really need the Elasticsearch, and we don't really need the Kibana unless we wanted to be able to go back and look at those logs at a later time. Then the Elasticsearch and Kibana is necessary. We could get by with this solution that we're talking about with just Logstash and Kafka. But we'll go ahead and we'll throw in the Elasticsearch and the Kibana just so that you guys can see the graphical user interface, the ability to search for log messages, etc., etc., etc. Now, Kafka, we haven't talked about Kafka yet. Kafka is a separate project that is operated by Apache. Yeah, that Apache, the Apache that you're thinking of right now. The same one. Kafka is, if you call it a message bus, someone will get mad and throw something at you. I think the word that they like to use, they call it a message queue. But the idea is you've got this platform that you can send messages to, and things can listen on that message. It's not a really good analogy for it. Let me think about a better way of phrasing how Kafka is coming from a network engineer's perspective. Kafka would be, well, there's nothing really like Kafka in the networking world, I guess. So let's think about a better way of phrasing the role of Kafka within the environment. Kafka it gives you this ability to publish messages to, we'll just call it a message queue. And then other applications and other services can listen on that message queue for these types of messages. Now, so it's kind of like what we call a pub sub model, right? Where you got publishers that publish messages and you got subscribers that subscribe to messages. Think of it as, hey, I was about to use multicast. Let's not use multicast because that will turn everyone will close their browser and say, I'm done. I'm out of here. And you really shouldn't. Multicast is actually pretty cool. But instead of a multicast analogy, let's talk about cable television, right? You remember that thing? Remember that thing we used to watch, like Saturday morning cartoons? I can't think of any Saturday morning cartoon. Captain Planet, remember Captain Planet? So anyway, we would have this television, right? And the television has different types of channels. And I'm explaining this to you in case you're rewatching this video in the year 2050 when televisions are no longer a thing. But the idea is that you have this television and you have multiple channels, and you use your remote control to subscribe or to turn on to a specific channel, and you get a feed that's being sent to you. So if you want to watch a male drama, you would turn on a channel called ESPN. And you would see all this drama related to male activities like sports, like football and blah, blah, blah. They would actually just talk about the drama. They wouldn't actually talk about the sport. But anyway, and if you wanted to watch cartoons, you could turn on to Cartoon Network. And that would you select the channel and you subscribe to it. Kafka is kind of like that kind of model, right? Where you got a publisher that's publishing to what we call a topic. Think of that as a TV channel. Right, so you've got an application that's just feeding messages into this specific topic channel. And then you've got your consumers, your average Joe that sits on their couch with a bowl of Cheetos. Who puts Cheetos in a bowl? I don't know. But they select the channel that they want to watch. And they only receive those types of messages, right? And they will continue to receive them until they close the channel or until the television blows up. Very similar. I hope that analogy makes sense because I came up with it on the fly. But the idea, again, is that the Logstash then the messages that come from Logstash are going to be the publisher. They're going to publish messages onto a specific set of Kafka topics or channels. So you can think of this as one producer or one publisher sending specific types of messages to specific types of channels or topics. And then we'll have a small Python app, a little Python container that will be the consumer. That will be that guy on the couch with a bowl of Cheetos listening to all the male drama of ESPN. And whenever a specific message is received on one of these topics, that container will say, aha, I got a message. I will now take an action because I received that message. So that's exactly what we're going to do. We're going to use our network devices to feed all the different types of messages that arrive from syslog to a collector. In this case, that collector is going to be Logstash. Now, Logstash is going to parse those messages, and it's going to say, this is a fan error. So I'm going to publish that to the Kafka topic called fan, right? And then maybe another message comes in and says, my BGP adjacency is down. I will publish that to the Kafka, same Kafka message queue, but on a different topic. Maybe one for BGP related notifications, right? You can kind of see the pattern here. We're basically creating these different topics on a Kafka message queue, relating to the type of error or the type of event that's going on. And then from the consumer side, we're going to have a Python container consume the messages as they come off the queue. And as soon as they receive a message, they're going to take an action, and then they're going to continue listening onto that queue. In our case, maybe we say, whenever you receive this BGP adjacency issue, I want to kick off this Ansible playbook. And so the container will listen for that BGP message. When it receives one, it will make a REST API call to Ansible Tower and say, Ansible Tower, I want you to execute this playbook. And I want you to execute it against this book. Maybe the playbook is something as simple as, in an MPLS world, you're running two routing protocols. You're running an underlay. Maybe that is ISIS, or maybe it's OSPF. And then you're running a BGP MPLS VPN on top of that. So maybe if your BGP message says, hey, I lost my BGP adjacency to my route reflector, maybe you want to tell Ansible, hey, Ansible, go log into the router and make sure that its ISIS adjacency is still up, or make sure that you can still ping the route reflector. If you can't, then you know that you've got a specific issue in your underlay, and then maybe you can send a incident to ServiceNow and say, hey, ServiceNow, assign this to Byron and have Byron investigate why I can ping the route reflector, but I lost my BGP adjacency. So that's the kind of idea. Now, you could also have Ansible perform a corrective action on a device. Maybe you say, if you've got a situation to where you got a spanning tree loop in your environment, God forbid, you got a spanning tree loop. Maybe you want to say, whenever you see this spanning tree topology issue happen, log into the switch and shut down the uplink, right? Maybe for whatever reason, from a spanning tree perspective, you got an L2 loop, and maybe you think you got two uplinks, and you just want to stop the bleeding. So you could tell Ansible, hey, log into this router and shut down one of the two uplinks so that the loop will be stopped. It's a pretty good use. Here's a better one. On like Cisco devices, if you've got a trunk between two switches and you've got a mismatch on the native VLAN for that trunk, it's going to send you a ton of it's going to send you a ton of syslog. Maybe this will be the one we actually test out, because I think this will be easy to reproduce. So you would have a native VLAN. Let's say the native VLAN is native VLAN 1 on one side, and the native VLAN on the other one is 10. Both of your switches are going to send a syslog message, I think every 30 seconds, and say, hey, got a native VLAN mismatch on my trunk port. I want you to fix it. Maybe we have the Python consumer say, hey, I see that spanning tree that, we see the native VLAN mismatch. Log into one of the switches and correct the native VLAN mismatch. It should be, native VLAN should be 1, not 10. Somebody mistyped it. We could do that. Actually, I think that will probably be the easiest thing for us to reproduce and show. So pretty cool. That's the idea. And, the Python consumers can do more as well. You can have multiple consumers listening on the same topic. Kafka is a really deep subject. And to be fair, ELK can be a deep subject as well. We're going to basically be using these for a network engineering perspective, not really to get the most bang out of the service. We're not going to be deploying things in a highly available environment. This is strictly for development. So don't take what we're doing here and think that you can roll this into production and be ready to handle the load of a full production network. Become good friends with your server team, right? Become good friends with your application team. Figure out what it is that they need and see if you guys can come together on a nice solution. All right, so back over here in our Linux machine, I'm going to need to do a few things. Actually, let's go ahead and just do all this from Docker. How about that? Docker's pretty easy. I think we can deploy all 4 through Docker. And so let's go ahead and do that. All students, classes in session, professor. Oh, geez. Yeah. Hey, I'm actually, I've accelerated my balding since the corona. So perhaps I will meet the typical perception of a professor. Maybe one day. We'll see. I'll work on it. Okay. Our first thing is to make sure Docker is still installed. This is the Linux development instance that we were working with last time. Let's just run Docker PS. Hey, we've got it. And we've got Docker. Oh, we've actually got Ansible Tower still running on this thing for 3 days. Has it really been 3 days since we used it? I thought it was last week. Yeah, it was 6 days ago. Maybe I rebooted the VM. Let's see if that Ansible is still a thing. Localhost. Just kidding. Localhost. Oh, no, it is. Localhost. All right. My password. Automation. Juniper123. Hey. All right. Great. Hey, I've got a bunch of failures, it looks like. Just 288 failures today. No big deal. I bet that's my automation. That's my Netbox source of truth dynamic inventory script. Let's go ahead and change into the Netbox here and Docker compose up. Oh, source. And Docker bin activate. Let's go ahead and fire up Netbox. Cool. Hey, I learned something really cool this week. One of our friends on Twitter shared this amazing project. And I think it's applicable for what we're doing here. So let's go ahead and create a new window. And let's close out the old one. And let's also at the same time find out, I think I have to install Node in order to get this Mermaid Markdown. So this is a text editing tool that allows you to build workflow and diagrams and stuff like that. That may be helpful for kind of mentioning kind of the workflow of what we're doing here. Really, really cool tool. Like within the first 10 minutes, I had it up and running and created a diagram for one of my customers, and it went over quite well. Very cool project. Let's go ahead and see if we can't go ahead and install this. I forgot if, yeah, I need to install npm. Or or is it just yarn? Let's see. I'm gonna guess that was the right project. Typically, don't be like me. Don't just install things just because you think it might be the right thing, because it's always more difficult to remove them from your system than it is to get them installed. I think this is going to be the right one though. So from here, we're gonna say, what is it? It's like yarn add mermaid. Is that the right way of doing it? Let's try it out. Okay. Well, maybe we won't do the workflow diagram. Oh, you know what? I think I put one up on the Twitter world earlier today. I think this is my name. Hey, I got it. That's my face. Wow, they really blew my face up. Thanks. Thanks for the glow up there, Twitter. So yeah, this is a good representation again of the workflow. Network devices are going to send syslog to our Elasticsearch or to our ELK stack. Logstash is going to receive the messages. It's going to parse them. It's going to put them in specific topics and then it's going to punt them over to Kafka in specific topics. Kafka is then going to have Python consumers listening to it, and then it will take corrective action. Okay, cool enough. I hope that makes sense. Let's go ahead and install our first one, which is going to be Logstash. Elasticsearch install. I've done this. It was sometimes last year, so I hope you're comfortable with me kind of stumbling my way through this. Okay. Hosted Elasticsearch. Yeah, we're not going to do that. We're not going to give them money. So it looks like we've got some Debian packages, which is really cool. We could easily install this through I guess the apt install. Hey, this is the one we're looking for. Install Elasticsearch with Docker. Is it Elasticsearch I'm looking for? I thought we were going to, we got to do Logstash first. Let's come back up to here and say Logstash Docker install. Okay, easy enough. Literally one line, or at least to grab the container. All right. Let's figure out whether or not we're going to have a lot of configuration. I don't think we have a lot to configure on the Logstash. I think we basically need to tell it what ports we want it to listen. Actually, you know what we do is we create a Logstash configuration file, and that configuration file tells it things like, I want you to listen for syslog, I want you to listen for SNMP traps, for NetFlow, etc. Right? So we're going to create a configuration file for Logstash and tell it exactly, what I want you to do, and then from there, let me see. Yep, we're good. And that's really it. There's going to be more to it eventually when we start getting in a little bit more complicated, or not complicated, but complex, to say like, hey, here's the grok message. Here's what I want you to match on. And this is the action that I want you to take. So we say configuring Logstash for Docker. So we're going to run the command docker run. Just so that you know, this --rm means if the container was to stop for any reason, go ahead and destroy the container. That makes it so that your container is like really, You got one shot at life, right? No extra lives. If you die, you die. You're done. And there's a sign for our own mortality. But that's effectively it, right? The container is just, if it dies, it dies. Then start up another one and carry on. IT, as we know, is interactive terminal. It gives us the ability to kind of get into the container and run around and do our own thing inside of it. Really bad explanation. V, so we're going to do a volume mount. That's where the V comes in. It looks like we're mounting a directory on our local machine called pipeline in our user directory. That's what that is. And we're going to be binding it to the container at user share log stash pipeline. Okay, good enough. And then we tell it here, I want to run this container image, the one that we just pulled down. So pretty easy enough. It looks like we're just going to want to probably create a directory on our own local machine. In this case, they called it pipeline. I don't know if I really like that word. Let's call it log stash, because that's what it is, right? And let's say docker run, and yeah, we'll do the --rm it and volume mount for the directory called log stash, and we're going to mount it at user share log stash pipeline, and then we're going to give it the name of our directory, which is this one. And okay. Yeah, so I forgot to tell you, this is one of the reasons why I like to run this inside of Docker instead of on your host operating machine, is that all elements, I believe all elements, yeah, all of them require Java runtime. And that itself isn't terrible. I don't necessarily hate Java. I'm not smart enough to have an opinion on it. But I will say installing Java on different operating systems can be a nightmare. It can be a real pain in the butt. And that's kind of taking it lightly, to be honest with you. So if you run it inside of a container, well, you don't have that problem. Now it looks like our container stopped. I got an error here. It says unable to retrieve license from server. Yeah. What kind of license are you talking about, man? We're doing the free version. Don't tell me that you want me to pay for the container. That's not gonna fly. We'll rip this sucker right out. Is there another error? Is there another reason that this thing failed? License check reader unable to, yeah, who cares? Unable to, failed to fetch the XPack information from Elasticsearch. So just so that you know, the XPack is kind of like an add-on functionality inside of Elasticsearch products. They call them XPacks. I don't know. I hear that word and I think of what was that wrestler from the 90s? Was it like, it was Triple X and then was it X-Pac? I don't remember. There was a wrestler. He used to, never mind. I'm not going to do it. That's what I think of when I think of X-Pac. Likely, yeah. So, okay, that's fine. I think the reason why it failed is that this one right here, no configuration found in the configured sources. That makes sense, right? The only thing we've done so far is we've created a local directory called logstash, and then we mounted that directory into the container. We didn't actually create a directory. So if logstash is looking for a config file, it didn't find one, and maybe that's why it died. I have a feeling that this is the error that broke the camel's back. So we'll continue with our exploratory efforts here. Let's see. If you don't provide a configuration of logstash or run minimal config that listens from the Beats input plugin. That's interesting. So Beats are kind of they're also like pluggable plugins. just really wanted to say pluggable plugins that allows you to add additional functionality within Logstash. It says that if we don't have a config file, that it'll automatically load up. I'm starting to doubt that. So this is the behavior that you're observing. Yep, that's fine. The image provides several methods for configuring settings. The conventional approach is to provide a Logstash YAML file, but it's also possible to use environmental variables. Okay, yeah, that's fine. Okay, so here they're actually just building the Docker container with, oh, it looks like they're removing the already configured Logstash file and then they're adding their own. It's kind of interesting. Let's see if I've got a good Logstash example. Let's do Logstash example config file. There we go. All right, let's try to run our container again now that we've got a config file listed here. We'll see if we get the same error message coming in. At the same time, we'll open up a new terminal and check our current running Dockers. Boy, we got a lot going on here. So we have these for AWX. Then we have all of these for the netbox. And then we've got this one right here, which is acting as our Logstash container. Let me see here. It looks like it's... Okay, it looks like it's listening. Now there is a problem, and we're getting the message right here. It's saying the Elasticsearch is unreachable. Now it didn't magically try to connect to Elasticsearch. The problem is that in the config file right here, this is the Logstash config file in all of its glory. And here we're telling it your input is standard in. We're going to change that later to be syslog. And then we want it to filter. So we're going to run this. These are the grok filter things that we had talked about earlier. You can tell it's kind of regex, not really though. And then we're telling it what to do. And this is where it's getting mad at us because it's saying, I want the message to be outputted to Elasticsearch. And then here's the instance of Elasticsearch. It's at localhost 9200. But you know, and I know that that is not a thing right now. Elasticsearch is not online. So it's complaining and it's going to continue to complain until we stand up Elasticsearch. But let's go ahead and run through the test to make sure that we get what we're expecting to get here. So I'm going to do a really quick curl to my local instance. Where is the... Oh man, I thought they had a really cool... you should see something like this. Paste the following line in your terminal. Press enter. Okay, we'll do that. I don't really like this though, but let's go ahead and hit paste. Yeah, I don't think that's the right way to do it, man. I don't think it's expecting us to run this in the foreground. Paste the former message right here. Into standard in. Yeah, I don't ever use this standard in plugin, so I'm probably doing this incorrectly. Let's test. Let's do a curl. And what are we? We're listening on port. I think it's 9200. Oh, we're not even listening on port. It's literally standard in. Yeah. Okay. This is cute, but it's not really the droids that we're looking for. This is a little bit more applicable. This is where we're passing Apache logs. Here you can actually see the input in a little bit more fleshed out concept. We're going to change this to be, I think we're going to tell it to listen to a UDP port 514. There is a syslog parser that you can run. I don't like it, and I don't use it. And the reason, and it may have changed, it may have gotten better. My beef with it, I got beef with it. My beef with it is that I feel like the input filter for Logstash for syslog is for like server type of logs, but we all know like networking logs are different. Although there is a standard format for them, not all vendors follow that format. Not all vendors follow their own format across all their operating systems, but we're not here to make fun of people. Logstash input, we're going to call this syslog. So let's look at the input for syslog filter. I'm sorry, the syslog input for Logstash, and I'll show you kind of what it looks like, and then we'll ignore it. Okay, so this is what I always do. I don't know if you're like me, right? There's all this great documentation whenever I search for something, and then I just like immediately scroll down looking for an example. I'm like, yeah. Just shut up and tell me what it is. We'll go ahead and run this, and we'll see what it comes out to be. Let's go ahead and actually start working on this Logstash from our local directory. Sorry for the white on white complexion there. Let's look at our Logstash config. Okay. Let's go ahead and control all, control remove, and let's just stick with the inputs for now. I think that's fine, and I think we can get rid of this one too. And we're going to tell it to listen on port 514. I'm pretty quite sure that is the right port. Let's restart our container because it's got a new configuration file, so we're just going to restart the container. And let's get a network device online to start punting some syslog over to us. I think that'll be fun. In the meantime, let's spin up Eve. Oh, that's cute. That's cute. Firefox, I adore you. HTTPS? I don't know. Eve. Oh. Okay. HTTP Eve dot fountainhead dot home. Yeah, I'm worried about this. Let's just ping Eve. Firefox is being ridiculous. NS lookup Eve dot fountainhead dot home. See, resolve. I'm trying to find my. Let's hard code our DNS settings and see if that helps us here. Because gosh dang it, I don't remember the IP of my Eve server. I've got way too many servers going on. So, oh, we're already right here. Okay, wired, connected. IPv4. Man, that's got the right DNS. That should have worked. That should have worked. We are hard coding our. This is the one thing I don't like about Ubuntu Linux. They think that they are satisfied with using systemd to do DNS resolutions, and this is the type of thing that drives me crazy. Let me 127.250, 251. There we go. Jeez. That wasn't hard. Not hard at all. Great job, Ubuntu. I adore you, and you frustrate me. Let's do a reverse lookup to see what the holdup is here. Yeah. God bless you. Okay. I guess we'll just hard code the IP in our browser and we'll be on our merry way, because I don't have the patience to troubleshoot DNS issues with systemd. All right, Eve, admin. We'll just go ahead and move this down here. Oh, dark mode looks horrible. Let's turn that off. Okay, that's a little bit better. Hey, look, we already got a Juniper MX and a Cisco switch, and they are already connected to the physical LAN, and we have a Ubuntu server. So it looks like we're in a good position, actually, to make some configuration changes to send syslog to our device. Let's log out of the HTML5 browser because I just don't like it. Oops, sign out. And let's change that to the native console. And what's running? Spring Campus. That's fine. So what we're going to do is we're going to configure the VMX Juniper box and the Cisco switch to start sending syslog over to our merry way. There is a Eve ng Ubuntu client package that I need to install in order to make Telnet work natively from the browser. This isn't the page I'm looking for, but it'll put me in the right direction. There we go. Linux client side. Linux client integration. Blah, blah, blah. There we go. See, I told you. I just look for examples and go on our merry way. Yes, that's fine. It's 7 o'clock here, so I'm gonna go ahead and start drinking. I hope you don't mind. Tonight we're enjoying a special vintage of San Pellegrino sparkling water. It's absolutely fantastic. Highly encourage you to give it a shot. This is the 2019 vintage sparkling water. Just the absolute amazing. Okay. They are recommending that we add our local user to the Wireshark group. Okay, we'll do that. And now I should be able to say abracadabra and click on this link. And that, yes, there we go. And now that'll open up a Telnet link. Hey, there we go. And I clicked on the wrong box. Let's click on the RE. And let's go into edit and set system syslog structure data. The host is going to be my host IP. Just kidding. Grep 10.255. There we go. 10.255.46 and 2. All of you tool fans out there know what I'm talking about, right? Tool Army, represent. If you don't know, then yeah, you never will. That's fine. To the host is going to be this IP, and we're going to tell it to send structured data. Yes, we want the message to come through as structured data. Let's also say, okay, we're starting a brand new, so delete chassis auto image upgrade. We're going to do a set system root authentication plain text password. So we're going to set a root password on our box. I'm also going to services enable SSH and enable netconf over SSH as well. We're also going to set a system login of user automation. Class is going to be super user, and the plain text password, authentication plain text password is going to be Juniper123 super secret password. Don't tell anybody. We're still friends. And let me see here. Run show interfaces. Is it FXP0? It is. That's where my IP address is. And for me, it is 95.223. Okay. That's just good to know. Ooh. Show compare. Okay, good, good, good. Let's also set the host name. Host name is going to be, I don't know, Tool Army. All right, and let's go ahead and commit that change. Okay, great. And I think I remember that I forgot to do something on the Cisco switch. Yeah, I think I forgot to create a username. I enabled AAA new model, and I'm pretty sure I forgot to set the username. Oh. Oh, that's because I enable. Hey, so for this being a development environment, I just did show running config include AAA, and you'll see what I'm talking about here. This local none. Don't do that in production. Don't be like me unless you have an up-to-date LinkedIn resume. Let's go ahead and actually create a username automation class, or I'm sorry, privilege 15. Secret is going to be Juniper123. And the name of my Cisco switch is I wish I was Juniper. Because we all know it does. It does. All right, great. Oh, we're also going to set the syslog. So we're going to say syslog or logging server. Logging, it's just the IP of our device, 10.255.46 and 2. And then logging, how do I tell it what level of logging I want it to send? Let's do this. Okay, logging host 10.255.46 and 2, and then transport VRF. You can actually send an XML. Hey, that's pretty slick. All right, do write memory. Still didn't see what I was looking for. Logging facility. That's it. Logging facility. No, I don't think that is it. There's a way to set just like what's the appropriate logging level in order to send it over to the syslog server. It's not buffered. It's not console. I want to believe, I thought it was host, but it's not. Is there anything else in here? Nope. Okay. We'll cross that bridge when we run into it. Where are we at as far as our container goes? Our container is it running again? Dude, I thought we shut it down. What was the last command I did? Oh, okay. Let's run that again. And back on our config on port 514. What's the good way on Linux to listen to figure out what ports you're listening to? It's like natstat-nr listening ports. Actually, I'm going to remove this because natstat listening ports. There. Sudo netstat. Okay, let's do that. And on here, I want to make sure that, you know, there's two problems. One is I didn't tell the container to listen in on port 514. So that's already going to be an issue. So let's go ahead and make the container listen on port 514. Okay, and we're going to do that by saying, I think it's -p. It's been a long time. 514 to 514. We'll pretend like that's right. Let me just do a Docker PS to validate. Docker PS will show me the ports that I'm listening to. Yep. Oh, 514 on TCP. I want it on 514 on UDP. So let's consult the gods over on Stack Overflow. Let's say Docker listen port UDP. Oh, looks like I just flag it as /UDP. Easy enough. Break the container, and we're going to say /UDP. Although I think some devices do send syslog on 514 on TCP. Hey, there we go. Cool. Good to know. So all interfaces on my host machine will listen on port 514 and forward them to the container on port 514. That's how we get the syslog love flowing through. Great. Exciting. Exciting. And I think that's good enough. Oh, shoot. We forgot to tell it to dump out to the local console, didn't we? I don't think we need to do that just yet. I think we'll get the messages inside of this console. It'll be ugly, but we'll still get them, and we'll validate that things are working. Look at this. We would have missed this one. I've run into this before too. So syslog listener died, protocol TCP, but it also died on UDP. So the reason that this is failing is that my host operating system, my Linux box, doesn't want me to be able to tell it to listen on port 514, because 514 is one of those well-defined ports that falls in port 0 through 1024. It wants you to pick something outside of that range, one of the extended ports. And so we've got a couple options. One, I think I can run this as sudo, and I think that's going to be enough. We can give it like King Kong access and say, no, you're definitely going to run this. That should work. If it doesn't, another option for us is to tell the host operating system to listen on a different port and then just translate that to the container on 514. The reason why I don't really like that is that you have to go back to all of your networking devices and say, okay, I want you to actually forward syslog on port 5514 instead of 514 or something along those lines. That is annoying. That requires a ton of configuration changes. So, yeah, that is going to be a problem. Let me see. Looks like we're running into the same issue. Is it? Where's the 514? There we go. Yep. Looks like the syslog listener died. What a shame, man. What a shame. So let's go ahead and let's do the poor man's port forwarding method. We're going to listen on port 5514 instead. And we're going to go ahead and remove sudo from this. This should allow us to listen in on port 5514 and be on our merry way. Speed and intensity is what Java is known for, right? Okay. While that's going in the background, let's go ahead and start talking about the Elasticsearch part. Let's go ahead and stand that up as well. For Elasticsearch, let me just try to guess the URL. Elasticsearch. Ah, okay. We tried. We tried, Twitch fam. Oh, I don't want this, man. Let's say Elasticsearch Docker container. Oh, coming back over here. Did our starting syslog listener died on port 514? Why is it still listening on port 514? Is the container itself preventing 514 to be bound to? It sure looks like it. It seems like a huge design flaw if that's really the case. Let's do this instead. Oh, this is starting to get pretty ugly, guys. In the meantime, we'll go ahead and pull down the Docker image for Elasticsearch. Look at that copy paste skills. There's none better in the game. Forget about it. Elasticsearch also has a... Do they have a config file? I don't know if they do. I think it's pretty cut and dry. I think this is literally the only thing that we need to do on the Elasticsearch side. Just expose port 9200 and 9300. Yeah, I think it's a little bit more complicated when you're doing clustering, obviously. But for us, I think this is really it. Oh, yeah, I remember this set in the VM heap message. Let's see. Just watching closely because I'm expecting this to be an issue for us. I'm really sad about this. Okay, so what we're going to need to do is we're going to need to make an adjustment. The container is not happy on listening on ports 5514 or on 514. So we're going to change it to 5514, and then we're just going to say forward this over on 5514. What a shame. What a shame. All right, now let's run the Elasticsearch at the same time. Actually, where's our log stash config where we were punting it to? Yeah, let's go ahead and include this in our log stash config file. There we go. And we will break this, break, and hit the enter key. All right, so 2 of the 4 components will be up and running on the ELK stack. The Cabana is just the GUI. Excuse me. It's going to be much easier to stand up because, well, it's a GUI. There we go. It looks like the Elastic box is coming online. It's sending us all kinds of pretty logs. That's good to know. Let's take a peek and let's keep our eye on the ELK, or I'm sorry, the log stash. That's the one that is going to have problems, or that's the one that will complain when it has the problems. In the meantime, let's validate our syslog. Seems like it's good. Run show log messages. If my dogs start barking in a second, don't get surprised. Don't get angry. But my wife just made it back from her errand. I called it. Last 100. All right, so we've got some log messages coming through here. The hope is that these are going to get punted over to our container. Okay, let's come back over here. And all right, so we didn't get the error this time. All right, we didn't see that the syslog died because we were telling it to listen on 5.14. So unfortunate. I wish it could be different, but this is kind of what we're going with. No, this is interesting. It says it's unable to reach localhost 9200. That makes sense when you remember back on the demo that we did for standing up Ansible Tower. We ran into a very similar thing when we were trying to do the dynamic inventory. We can't tell it to listen on localhost 9200 in this case because from the container perspective, it is localhost. So what we really needed to do is say, listen on ports. Where's our config file here? Fantastic copy pasta. Yeah, man. It's the top of the game. Top of the game. 10.255.46 and 2. And that's going to be our config file. So sorry to do this again, but we're about to restart the container because we need a way to tell Logstash, listen or try to connect to Elasticsearch on the IP of the physical host, right? Not localhost. So let's run this one. Where is it? Right here. Boom. Ooh, wait a minute. That's 5.14. 5.14 was not right. It's supposed to be 5.5.14. 5.5.14. We're going to need to update our network devices configurations as well to make sure that they forward this over on port 5.5.14 instead of 5.14. Let's do that now. Set system syslog, and our option is server and 10. Host. There we go. Is going to be 10.255.46 and 2, and then we can say the port is going to be on 5.5.14. It's easy enough on the Juniper side. Let's take a peek. Oh, let's also say I want you to send any facility and any severity. Boom. Let's do a show compare. Show compare. And looks good. Let's go ahead and commit that. And let's go over to the Cisco box now. Cisco switch 14. Just kidding. The real name is I Wish I Was Juniper. Automation and Juniper 123. And then get into that enable prompt and say conf t logging host 10.255.46 and 2 and no. How do we force the port on a Cisco box? I keep wanting to think. Let's just say logging 10.255.46 and 2. Not finding it out. Let's ask the Google Lord. Cisco switch syslog port. It's interesting. This post was from 2011. Hey, it's Peter. Hey, Peter. Of course he's a Hall of Fame Cisco employee. Logging host. Yeah, I don't know if that's really the case on our box, though, is it? Let's see. Wait a minute. Why did it try to get to that URL? Oh, okay. Where's our box here? According to Peter, back long ago, we're going to say, looks like we were on the right path. Logging host 10.255, 46 and 2. Question mark is transport UDP port 5514. Good job, man. Good job, Peter. You're the best. Do write memory. Let's make sure we've got a... okay. Let's make sure that we've got an IP address on this. Do show IP interface brief. Exclude unassigned. And we do not. So if we say do show run... Can I do section on here? Yes. Interfaces. All right. So we got gigabit 0, 1, 2, and 3. And on my Eve box, I am listening in on gig 3. Okay. So interface gig 03 is going to be IP address D. No switch port. IP address DHCP. That's going to be good. All right, and then we're going to say, oh, are we getting some goodies over here? Still complaining about the license server. It must be a new thing. I don't remember Elasticsearch crying about that. Okay, so looks like interface gig 3 came up with an IP address and the host name. I wish I was Juniper. Okay. And let's do ping 1.1.1.1. Hey, I got external connectivity. Let's try to ping our syslog server. 10.255.46 and 2. Not responding. Man, did I have the right IP on this? That'd be rather embarrassing. Yep. That looks good. Is there some kind of weird firewall policy. What is my IP address on this one? Okay, and then let's try to ping from here to there. Can't seem to ping the switch, but I can, from the switch, I can ping out. Is this a, I think this might be a VMware issue where I'm not allowing intra VM communication. Let's load up vCenter and figure out if that's really my problem. Ah, Firefox, I hate you. HTTPS vCenter. Oh. Let's do again another NS lookup for server 10.255, 127.250. And vCenter vCenter.fountainhead.home. Hey, there it is. Actually, I don't know if this is going to work because the browser is going to do a redirect. Yeah. Okay, let's do a poor man's DNS. Sudo vim etc hosts. Don't be like me, guys. We're going to paste in this and we're going to say this is vCenter. Anything to get around those DNS issues, right? Let's also do vCenter. Oops, come on. vCenter.fountainhead.home. And again, this is only because Ubuntu thinks that systemd does a good enough job with DNS, and I beg to differ. Let's do a ping vCenter now. Now it works. Okay, refresh our web browser. Advanced. Go ahead and load it up and do it again and accept. Now I got to enable Flash. Oh, don't tell me that's going to be You ever installed Flash, Adobe Flash on Ubuntu? It's a nightmare. Let's go ahead and just do the HTML5 client and get around our administrator at vsphere.local. And oh my goodness, I don't remember my password. Stand by. I'm going to use my Windows machine for this one. Good enough. So we're going to see whether or not my theory is right about the firewall on the virtual distribution switch in vCenter preventing the intra VM communication. Let's get out of here and let's go to our network settings. Looks like I've got this virtual switch. First of all, let's look at the VM that I'm working on, dev1. It's actually connected to a virtual standard switch. That's interesting. And then Eve is connected on VLAN 255. Let's do this. Let's kind of pull the rug underneath our feet and let's migrate away from the virtual standard switch to the virtual distribution switch that Eve is on. Then it'll be a flat L2 network. Let's do this. Let's do this. Let's do that. And let's see if our pingies are coming back alive now. Quit. Exit. Ping. Hey, what do you know? Our theory is right. Okay, so the problem that we had was that and let's try to do it from the switch. Very cool. The problem that we ran into was a VMware configuration problem. The virtual machine, everything that you're seeing that me do right here is on a Ubuntu Linux box. And I'm connecting to it through VMware Workstation. The reason why I'm doing it on Linux is that my host operating system right now is Windows. And I'm using Windows because Windows has the streaming software that I need. But if you've ever done any automation on Windows, you know that you don't get paid enough to do that. So we're using Linux instead. This is a virtual machine that you're looking at, and it was on a different virtual machine switch, a virtual switch, than that of Eve. So we just made them on the same L2 virtual switch, and now we can ping each other. Life is good. Okay. Now we can expect to start getting some syslog messages in between the two. Very cool. Very cool. Very cool. Okay, so the box here is still complaining, and it's complaining about, what's interesting, it's complaining about name resolution. Let's see if by switching up to the virtual distribution switch that suddenly my DNS problems go away. Let's do an NS lookup on Hoth. It does not. Hoth.fountainhead.home. Nope. Thanks, Ubuntu. Systemd is horrible. Don't do this to your users. Okay. So we've got Docker PS. That will tell us the containers that we have running. It looks like we've got the Logstash container that came up with the name of Strange Napier. Love it. And we're listening on port 5514 on UDP, and we're punting that down to Logstash. And then Logstash should be up and connected to Elasticsearch. I'm not seeing all of the log complaints. Here we've got our Elasticsearch instance, and it looks to be running. There's a lot going on. Looks like we're actually sending it Docker cluster information. That's interesting. Elasticsearch must be listening on some next level stuff. And yeah, I think we're good. Let's start trying to send it some syslog to see if it magically shows up in Elasticsearch. And we'll also, what else will we do? We'll get the companion, the Kibana part running as well, which is the graphical user interface. How to create a let me just try to do a commit comment, and we're gonna say this is a, just kidding, this is a comment. Commit was complete. I'm hoping to see the log messages rendered in the UI, but or from the CLI. I didn't see that. Still complaining about no connection to Elasticsearch at 9200. This is kind of interesting. Who told it to listen on that? Hey, Lemmy, come up here, bud. Lemmy, it's prime time, buddy. Get on camera. Say hi. Is there a reason why you're bothering me? Lemmy might need to pee. Lemmy has this. Oh yeah, that won't freak him out. Keep doing that tongue sound. That was the worst sound in the world. No, you good? All right. Lemmy has this amazing ability to like hold about half a gallon of urine in his little body. Don't you? He wasn't always potty trained, as no dog really comes out of from birth being potty trained. But Lemmy had this really unique thing about his through his potty training experience. He would not pee in one spot. Like he wouldn't, in urine, like when it's in a pool, it's really easy to tell, right? It's clear, cut and dry. It's like, hey, that's a pile of pee. And there's usually a smell that's associated with it. Lemmy did some next level stuff. he would pee and then he would start running around the house and he wouldn't stop. Right? So just imagine the mess that you would have to clean up from a little puppy just running around the house, peeing, peeing, and just nonstop. Again, it's like a half a gallon that fits in that little guy. Truly remarkable. All right, if you're just joining us, we're enjoying this vintage San Pellegrino sparkling water, 2019 edition, just absolutely fantastic. We have stood up our Logstash server. We've stood up the Elasticsearch component, and what's left for us to do is the Kibana and the Kafka. Now, we don't appear to have our syslog messages coming into the box just yet. I was hoping to see some kind of log messages sent from our devices. It doesn't look like that's coming in just yet. So there's probably some kind of issue happening. One of the things that I'm worried about right now is that we get this message, the URL HTTP localhost 9200. The name is not found or unknown. I'm trying to figure out where the heck it got that message or that configuration, to be honest with you, because it's not in our config. Our config is pretty cut and dry. This is where the Elasticsearch server is. So I'm not really sure where it's getting the second component from. But that's what live streams are for, to kind of stub your toe and figure it out with the pressure of people watching you. That's where we are. We had some DNS issues. That's always fun. Let's come back over to our Logstash config file. And this is fine. I think this is all good. We'll close the Twitter world. We'll close the Ansible. We'll close the Kafka. Close that. Close Netbox. Oh my goodness. We'll close ServiceNow. We'll close the Juniper SD-WAN. We'll close the middleware. We'll close Tower. Okay. Now let's take a peek again at the I think Logstash is legit. I don't think that's our problem. Let's go ahead and stand up the Kibana container, and we'll hopefully figure out what's ailing us right now. Okay. As you can see, standing this stuff up is really easy. It's more about talking through it. That's the problem. Let's copy this and come over to here, paste it. Oops. Don't change the web page. Stay right there. Stop. Stop. Okay. So it looks like for the Kibana, please stop. Kibana, we're going to need to set this environmental. So Docker run link your Elasticsearch container name or ID, and then Elasticsearch, and then port 5650, Docker repo version. Boy, they could have really made that a little bit more intuitive. So the Kibana also has a config file, but the config file looks a lot different than what we did for Logstash. The config file for Kibana is going to be in a YAML format. We'll see if we actually need to tweak that at all. I think the default settings are going to be sufficient for us. So we'll copy this command. We'll come back over here to check the status. Okay, just in time. So again, Docker PS, and then we're going to grep for the word Elasticsearch. Okay. So the name of my Elasticsearch container is this, or I could do it based on the ID. So let's paste this in here, and we will say Docker repo is this one right here. That's the one. We'll paste that in there. And the name of the container is going to be upbeat hype. Okay. We're just not even going to pretend like I can pronounce that. Let's click on this and hit that. All right. Starting to see some warnings. I don't know if that's a good thing or a bad thing. I'm still worried that we're not seeing the ports, the syslog. Oh, hey, look at this. We got some syslog came in here. Emergency host was 10.250. Okay, that's our Cisco box. Hey, good on you, Cisco. We got a syslog message, and you can see it here, right here in the console. You'll see that we have a grok parse error. That's because we haven't written a grok message, so Logstash doesn't know how to parse it. Right now, it's just this really long string of text. But pretty cool, right? We could see it actually did a pretty good job of parsing it, to be honest with you. It was able to tell the severity, the facility, the timestamp. Hey, not that bad. Really cool. And that's the message that came through. Did we get any others in the meantime? I'm hoping the Juniper stuff is working. The Cisco stuff's working. Hopefully the Juniper stuff's working. We'll take a peek. We didn't try to ping the Juniper box from our syslog collector. Maybe that's the problem. We'll take a peek at that. And this is the Elasticsearch. This is the this is the Kibana. All right. So Kibana is listening on port 5601. Let's go and visit that guy. Kibana 5601. Oh, just kidding. Localhost 5601. Hey. Very cool. I can see some logs happen in the background as the UI gets rendered. It's taking its time. Again, we're running a lot of containers on a virtual machine that's on another server in another part of my home. So if there's a little delay, I'm not really too worried about it. All right, had to disable dark mode, but it ruined my eyes. Let's go ahead and say for the Kibana setup, please, Firefox. We're gonna say explore on my own. Okay. So we need to tell it where to look for the data. And by that, we're going to say, I think it's down here at management. Is it here or dev tools? Let's go to management. And we're going to say index management. And is this? Yeah. Is this the one? So you can see that we're already pointing at the Elasticsearch. When we set up that config, that Docker command, remember we said, here's the name of my container, and here's the name of my Elasticsearch container. I think this is it. I think this is the droid that we're looking for. Let's click on manage index, please. Show index settings. Okay, just manage it, man. Manage. I'm sorry, Kibana. We need to create what's called an index pattern. This will reference the index pattern of the Elasticsearch. If none of this makes sense, don't worry. You probably don't even need to run either the Elasticsearch or the Kibana side, but we're just doing it because we want you to see the goodies. Okay, that should be it. If we come back over to our dashboard now, we should be able to see our syslog. Hey, 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 what do you know? I wasn't lying. Here, there's a syslog came in from the Cisco box. It says config console from automation on console. Really, really cool. Now, what we're going to want to do is we're going to want to set up a Grok parser that parses this string right here and then says, okay, this string, and we'll map it to a Python dictionary, or in our case, into a JSON dictionary, and then that will get punted out to Kafka. So really cool. So we got the full ELK stack working. Let's try to figure out what's the problem with the Juniper is the Juniper just doesn't have a problem and it's not sending syslog. Let's say show system, and let's look at syslog. And here is the message. We want it on. Okay, that's good. Let's try to ping 10.255.46.2. I think I know what the problem is. I'm gonna try to put the mic on pause as I sneeze. Trying to time it. Not working. Okay. Let's do this instead. I think the problem that I have is that I'm trying to send this out through the management interface? Run show interfaces terse grep 10.255. Okay. Can I do a run ping 1.1.1.1 and sourcing it from 10.255.95.223? Okay. Run show route. Run show route. I've got our default route out, but I can't do anything from it. So let's do this. Let us delete interface. Oh, actually, let's not delete the interface just yet. Let's do this instead. Come back to my Eve topology. I'm actually going to remove this connection and I'm going to bring it up on the FPC instead. And we're going to say FPC interface. Oh, interface 1 is good enough. I'm going to try to put this on the data plane port instead on the routing engine. Let's see. I'm going to say replace pattern FXP0 with GE001. Now I do a show compare. Okay, and actually let's not even do that either. Let's delete interface gigabit 001. Let's hard code the IP. We're network engineers, that's what we do, right? Set interfaces gigabit 001, family internet IPv4, and address is going to be 10.255.46 and 3/17. And we're going to say set routing options static route, and it's going to be 0/0. Next hop is going to be 10.255.01. We're going to commit that bad boy, and we're going to try to ping the VMX now from our local box here. So let's do ping 10.255.46.3. Doesn't look like it's working here. Run show ARP. That's interesting. I'm seeing, hey, there we go. Where'd it go? I got some replies and then some died. Let's 46.2. So that's interesting. Some of the pings are getting through, but only when I'm pinging it from the host. If I stop pinging it from the host, let's see if looks like we kick-started it up. Gave it a little jump start. Let's hope it stays like that. Okay, and let's do another commit message. Sorry. Commit comment. This is a test. Make sure I can still ping that darn thing. Hey, there we go. We got the syslog message in here. Tool army UI commit in process. The commit command is in process. So really cool. What I'm gonna want to run this actually in the background rather than continually monitor it in the foreground like I am. But we're good for right now. Okay, look, we got a lot of messages coming through now. Holy moly! I bet Cabana's going crazy right now. Let's open this guy up and refresh. All right. Yeah, we see the influx of the messaging coming through here. The VMX is just going to start spamming the living daylights out of this. Can I turn on dark mode again? My eyes just... How did we live without dark mode before? I don't know. Okay, that's good. That's nice and clean. So really cool. We got our messages coming through. What we're going to want to do, like I said earlier, is we're going to set up some grok parsers to look at this object right here, the message, and then make an intelligent decision on how to handle that message, which Kafka topic that we want to send it over on. But pretty cool. We stood up the ELK stack. I think we're in a good position. Let me see if we can do Kafka container. I'm worrying that I'm running out of time here. There is it Bitnami? Are they the ones that... there's another one. What is the name? It's like German. Let's do our amazing Google search skills here. And I'm going to say German Kafka container. And we're going to see if there's a... no, that's not... No, not Franz Kafka. It starts with a W. W-U-Z. Let's just search for that. Man, there's an excellent project out here around Kafka that someone has wrapped up inside of a container, and that's the one that I want to run because I know it works. But let's see if we can't find it here. Hey, there we go. Wurstmeister. Of course. It's funny. I haven't stood this up in almost well over a year. I feel like, and I still remember this. It's always the obscure stuff that I remember. Old rap lyrics from like 1991. Still remember them. Perfect to the T. But the important stuff slips. I think it's selective memory. I think I'm doing it to myself. Okay, so they actually want us to run this as Docker Compose. Is that right? This is let me see here. Docker file image is available at Docker Hub. It looks like they want us to run this as a Docker Compose file instead. And that's fine. I'm okay with that. Then advertise host name. Yeah, that was a big part. I remember that being an issue for me. And the listener config. All right. I'll tell you what, we're 2 hours into the stream. I need to go say hi to my wife. I know that she's had a long one. So let's go ahead and pause it right here. when we come back later on, we'll stand up the Kafka component, and then we'll add that as an exporter for the Logstash config. So down here, we're going to send it to both Elasticsearch, also the standard out, and actually we'll probably remove the standard out, and then Kafka will be the last one. And then we'll be up and running and off to the races. So thanks again for checking in, guys. I know it's been a long one, but we do get our ELK we do have our